Hello everybody, I am Syed on Mass Online. Today's topic is continuous probability distribution. To understand the definition of continuous probability distribution, let us first try to study what is a continuous random variable. A continuous random variable is a random variable with a set of possible values, and these possible values are known as range, that is infinite and uncountable. I will try to take the random variables with a set of possible values that are infinite and uncountable. Let me take an example of a random variable. The example of a random variable is the person's height. Example of the continuous random variable is a person's height. Suppose you want to calculate the person's height somewhere between say 4 to 6. And what are the possible heights, or what are the possible values? Suppose this value is 4 to 6 that I am taking, it will represent the range. So it's a certain range that I am taking. So the range can be somewhere between 4 to 6. So the height can be 4.1, 4.2 and so on. It can be 5.1, 5.2 and so on up to 6. So it can take different values over here, and all these values are continuous in nature. So therefore such type of random variables are called as the continuous random variables. This is one of the example. You can even try to consider an example where if you are taking a website and how many members are browsing that website per day. If you want to calculate that value, such type of example is also an example of a continuous random variable. Now let us try to see what is this continuous probability distribution. The continuous probability distribution, I have just written the definition so that you can just make a note of these definitions. So continuous probability distribution, the definition is a continuous distribution describes the probabilities of the possible values of a continuous random variable. So we are trying to calculate the probability of the continuous random variable. So you are taking this continuous random variable over here, and you are trying to find out the probability. So if you want to find out the probability, what is the probability that the person's height will be 5 feet? If you calculate in that way, so such type of probabilities will be called as a continuous probability distribution. Now coming to the definition of what is a continuous probability function or a probability density function. Now for the continuous probability function or the probability density function, suppose if I consider a certain function, say f of x, and this function, and this x is the variable, x is the variable that you have, and suppose if this f of x satisfies the condition that f of x is greater than or equals to 0, that is the first condition. And the second condition is that the integral minus infinity to plus infinity f of x dx, if this integral value comes out to be 1, then if these two conditions are satisfied, then such type of probability is called as a probability density function. In short, I can represent that as PDF. So if these two conditions are satisfied, if f of x is greater than or equals to 0 and integral minus infinity to plus infinity f of x dx is equals to 1, if these two conditions are satisfied, then we say that the given function is a probability density function. So whenever you want to have the probability density function, these two conditions has to be satisfied. I've just given it in the form of a statement over here, just for your reference. You can just make a note of this definition that I have given over here. So if for every x belonging to the range of a continuous random variable x. So once again you can take the same example of finding out the height of a person. So if you are taking this range to be equals to capital X and any value, suppose 5 feet you are trying to consider, so x will represent, small x will represent your 5, and this capital X will be the range. So if for every x, for any value that you want to calculate, you want to calculate the probability of finding out a 5 feet person. So I am taking that as x in this range, capital X range 4 to 6. So if for every x belonging to the range of a continuous random variable capital X, we assign a real number f of x satisfying two conditions. So as I told you, two conditions: f of x should be greater than or equals to 0. The second condition is integral minus infinity to plus infinity f of x dx will be equals to 1. These two conditions should be satisfied. If these two conditions are satisfied, then we say the given function f of x is called as a continuous probability function or probability density function, which is nothing but PDF. You just make a note of this definition, or you can just pause the video and make a note of this definition. I'll move on to the next result. Now here I've just taken a formula: probability that the value of x lies between a and b will be equals to integral a to b f of x dx. So suppose if you want to find out, so these are the continuous probability variable x. So if this x value can take any range between minus infinity and so on up to plus infinity. Suppose if we are taking the height of the person between say 4 to 6, and you want to calculate the probability that the person is of height 5 feet. Suppose if I take this as x, and if I take this value to be equals to a and this value to be equals to say b, what is the probability that this x value lies between a and b? That is what we want to calculate. What will be the probability that this value of x 5 feet will be lying between these two random values a and b? So you can calculate the probability of this value to be equals to, it is integral of, it is a to b because the end values are a to b, so I can write a to b f of x into dx. That is the basic formula. So whenever you want to find out the probability of any value x lying between any two random values a and b, you can use this formula: integral a to b f of x into dx. So that is what I have given the result over here. Probability when the value of x lies between a and b, integral a to b f of x into dx. So this formula we'll try to use while solving the problems. Now the next definition that I have is the cumulative distribution function. So let us try to study this definition: cumulative distribution function. So what is this definition? Suppose if we are taking x as a continuous random variable with probability density function, that is PDF, f of x. So if it is a PDF, it has to satisfy the two conditions. As I told you, f of x should be greater than or equals to 0. The second condition is that integral minus infinity to plus infinity f of x dx should be equals to 1, as I've shown you earlier. Then the function f of x, this capital F of x, can be written in this form: probability when capital X is less than or equals to small x will always be equals to integral minus infinity up to this x value, minus infinity to x f of x dx. So then this function f of x will be called as a cumulative distribution function, or in short we can call it as CDF, cumulative distribution function of this continuous random variable x. So that's the basic definition of the cumulative distribution function. Now let us try to see what will be the mean and variance of the continuous random variable. So let us take the mean. The mean mu is written as, the general formula will be minus infinity to plus infinity x into f of x into dx. That is the mean formula that we have for the continuous random variable. Then similarly, the formula for the variance, sigma square, or you can just write it as v. The variance v will be equals to, it is integral of minus infinity to plus infinity x minus of mu whole square into f of x into dx. It is one formula. You can write down the variance in another way also. It is integral of minus infinity to plus infinity x square f of x into dx minus of mu square. Mu represents the mean. So these are the basic formulas that we have. Let us try to take few examples based on this continuous probability distribution. Let us take the first question. Show that f of x is equals to 2x when the value of x lies between 0 and 1 and it is equals to 0 otherwise is a PDF. That means we have to show it is a probability density function. As I told you earlier, for a probability density function, two conditions has to be satisfied. The first condition is that this first condition, f of x should be greater than or equals to 0. The second condition is that integral minus infinity to infinity f of x dx should be equals to 1. If these two conditions are satisfied, we can say that this f of x is a probability density function or PDF. So let us try to show those two conditions. Let us take the first condition, f of x. Let us try to see whether it is greater than or equals to 0. So try to observe here, the values of x are 0 to 1. They are positive values. So if I put x to be a positive, 2 into a positive value will be a positive value itself. Therefore the value of f of x will be greater than or equals to 0. So first condition. So f of x is also 0 here, so equals to 0. So the first condition is satisfied. Now coming to the second condition, that is integral of minus infinity to plus infinity f of x dx. It should be equals to 1. So let us try to see over here. It is integral of, see, the limit values are from minus infinity to infinity, but the function is defined only for 0 to 1. For all the other values it is 0. So we'll just try to ignore the other values and take only the limit between 0 to 1. Only for 0 to 1 the value of f of x is how much? The value of f of x is 2x. So 2x into dx. Here 2 is a constant you can take outside. It is integral of x. Integral of x will be x square by 2. And the limit values are x is equals to 0 to 1. You can just cancel out this 2 and 2, apply the limits. So the upper limit value for x will be 1, so 1 square is 1, minus the lower limit value for x will be 0. So 1 minus 0 will be 1. So have we got that result? Integral minus infinity to plus infinity f of x dx is equals to 1. So both the conditions are satisfied. F of x is greater than or equals to 0. The second condition, integral minus infinity to plus infinity f of x dx is equals to 1. If both these conditions are satisfied, what can you say about f of x? Therefore f of x is a PDF. It is a probability density function. Now let us move on to the next question. So the question is, find the constant k such that f of x is equals to kx square when the value of x lies between 0 and 3 and the value of f of x will be 0 otherwise. So is a PDF. So that means we have to show that this f of x is a PDF. For that, two conditions has to be satisfied, and then we need to also compute these values. So the first case is you have to show that f of x is a PDF. For that, two conditions has to be satisfied. So and he says that if this function f of x is a PDF, then find out the value of k. So which means this function is a PDF. So taking this as a PDF, we have to find out the value of k. So the first condition is f of x is greater than or equals to 0. If the value of k is greater than 0, naturally x square is there, and the value of x is lying between 0 and 3, definitely the value of f of x will be greater than or equals to 0. So the second condition is integral minus infinity to plus infinity f of x dx is equals to 1. So it says it is a PDF, therefore this condition has to be satisfied. But the value of f of x is given only for 0 to 3. So therefore you can rewrite this for 0 to 3. And for 0 to 3, what is the value of f of x? It is kx square. So kx square into dx. Its value will be equals to 1. Right? So now k is a constant, you can just take outside, we will be having integral 0 to 3, x square into dx will be equals to 1. You can just integrate this one. So k as it is, integral of x square will be x cube by 3, limit values will be 0 to 3, its value will be equals to 1, or k times of, apply the limit over here, it will be 3 cube divided by 3 minus lower limit value will be 0. that will be equals to 1. So we'll get k times of, so we'll just be getting 3 square over here is equals to 1. 3 square is 9, so it is 9k is equals to 1. So the value of k will be equals to, so 9k is equals to 1 we have, therefore the value of k will be 1 by 9. So k value has been obtained. Now further the other results have to be found over here. Probability when x is lying between 1 to 2. That is the next result. So let's find out that value. So p1 is less than x, x is less than 2. That will be equals to. So now this is similar to the result that I have given to you. If you can remember the note, I have given the note over here. We'll go back to the note that I have given. Probability when the value of x lies between a and b, that can be written as integral a to b. So this limit a to b f of x into dx. So I'll be using this formula. Alright, just write a to b f of x into dx. So now if you rewrite, it is integral of a to b. What is a to b? A to b is 1 to 2. F of x into dx. So what is f of x between this value 1 to 2? So f of x for 0 to 3 is kx square. So 0 to 3, this 1 to 2 lies between that 0 to 3, therefore it will be kx square into dx. But what is the value of k? The value of k is 1 by 9. So just you can write integral 1 to 2. K value is 1 by 9. 1 by 9 x square into dx, which will be equals to 1 by 9, the constant outside. Integral of x square will be x cube by 3. Limit values will be 1 to 2. That is 1 by, just multiply 9 3 times, it will be 27. Apply the upper limit value, it's 2 cube. Lower limit value 1 cube will be 1. So which will be equals to 2 cube is 8. 8 minus 1 will be 7. So 7 by 27. That's the first result you will be getting. Now let us move on to the second result. The second result, if you observe the question, the second result we have is probability when the value of x is less than or equals to 1. So which means that if you write down again integral of less than or equals to 1, so the values will start from minus infinity up to what value? Up to 1. Usual integral value that we have is from minus infinity to plus infinity f of x into dx. Alright. So here lower limit value is not given. So lower limit value will take it as minus infinity. Upper limit value maximum here is given as 1. So we'll be taking it as 1. And the same function f of x into dx is there. F of x is kx square. Right. F of x will be kx square. Or you can just write it as what is we have f of x into dx. That will be equals to, but if you go back to the question is, the value is defined only for 0 to 3. I can rewrite this as minus infinity up to 0 f of x dx. Again integral of 0 to 1 f of x into dx, because the value is from, say, from minus infinity up to it is 1. Alright, this is minus infinity somewhere over there up to 1 value. Alright, which means what I am doing is I am just dividing, I am taking from minus infinity to 0 1 value, again from 0 to 1. So, but from minus infinity to 0, its value is given as 0. You can see over here in the question f of x is defined only for 0 to 3. For all other values, value of f of x is 0. So therefore this particular value will take it as 0. So this value will be equals to 0. Integral of 0 will become 0 itself. Plus you have integral 0 to 1. F of x value is k x square into dx. 0 you can ignore. The value of k is 1 by 9. You can take 1 by 9 outside. You have integral 0 to 1 x square into dx, or 1 by 9. Integral of x square will be x cube by 3. Limit values will be 0 to 1. We just multiply 9 times of 3 is 27. Upper limit value will be 1. 1 cube is 1 minus lower limit value will be 0. So we'll just get 1 by 27. That is the second result we have. Now move on to the third result. Third result, if you try to observe the question, it is probability when the value of x is greater than 1. If it is greater than 1, so integral value that you have from 1 onwards, right? So greater than 1, so from 1 onwards it starts. From 1 onwards it is up to infinite, but here the value is defined only up to 3. You can see that the value is defined only up to 3. F of x is defined only up to 3. Beyond 3 the value is 0. So we'll take up to 3. 1, 2, 3. The function value is k x square into dx. But the value of k is known, 1 by 9. So I'll take 1 by 9 outside. Integral 1 to 3 x square into dx. So it is 1 by 9. Integral of x square will be x cube by 3. Alright, limit values are from 1 to 3. So it is 1 by 27. Upper limit value will be 3. So 3 cube minus lower limit value will be 1 cube will be 1. Or 1 by 27. So 3 cube is 27 minus of 1. 27 minus of 1 will be 26. So 26 by 27. That is the third result. Now let us move on to the fourth result. If we read the question, it is asking us the mean. Mean mu, the formula that we have is minus infinity to plus infinity x times of f of x into dx. But limit values are defined only for 0 to 3. For 0 to 3 x into, what is f of x? It is kx square into dx. Or that will be equals to, plug in the value of k to be 1 by 9. 0 to 3, k value is 1 by 9. X square into x will be x cube into dx. It will be equals to 1 by 9 integral 0 to 3 x cube into dx. Integrate x cube, you will be getting 1 by 9. X cube integral will be x power of 4 by 4. Limit values will be 0 to 3. 9 times 4 is 36, so 1 by 36. Upper limit value will be 3 power of 4 minus lower limit value will be 0. Or you can just simplify that one and write down it will be how much? 81. 3 power of 4, 81 by 36. Or if we cancel out, we'll be getting 9 by 4. Alright, that is the fourth result. Now fifth result, again check the question. The question is asking us to find out the variance. The variance v will be equals to integral of minus infinity to plus infinity x square f of x dx minus of mu square. I have given you two formulas for variance. I am taking the second formula, which will be equals to integral. So this integral is defined only for 0 to 3. X square, the value of f of x is kx square into dx minus mean mu, just now calculated the mean value to be 9 by 4 and it is squared, which will be equals to, it is integral of 0 to 3. K value is 1 by 9. So 1 by 9, you can take that 1 by 9 outside. X square into x square will be x power of 4 into dx. 9 square 81 divided by 4 square will be 16. That will be equals to 1 by 9. Integrate x power of 4 will be getting x power of 5 by 5. Limit values will be 0 to 3 minus of this 81 by 16 as it is. This is 1 by 9, or you can just multiply. 9 times of 5, 45. 1 by 45. Upper limit value will be 3 power of 5. Lower limit value will be 0. 81 by 16 as it is, which will be equals to 3 power of 5 by 45 minus 81 by 36. Just try to evaluate this and check what's the value you're getting. Are you getting 27 by 80? Then it is the right solution. So we have the question, find the CDF for the PDF of a random variable x. F of x is equals to so much. CDF represents the cumulative distribution function. Alright. So I have given you the formula for the cumulative distribution function, capital F of x to be equals to, it is integral of minus infinity to x. Alright. It is f of x into dx. That's the basic formula I have given you. So let us use that formula here. It is f of x is equals to, it is integral of minus infinity to x f of x into dx. That is nothing but integral of, I can just break this interval from minus infinity up to, because it is defined from 0 to 1, so I'll stop from minus infinity to 0, f of x into dx, plus again from where I have left 0, I have to start from 0 up to what value? Up to x, into f of x into dx. So the function is defined only from 0 onwards, Before 0, the value will be equals to 0. So this value will become 0. Plus you have integral 0 to x. What is f of x value? F of x value is 6x minus x square. It is 6x minus 6x square into dx. So let us just try to integrate this one. It is 6 is common, you have integral 0 to x into dx, just multiplying it, minus here 6 is common, integral 0 to x, you have x square into dx. Now if you try to integrate this expression over here, that will be equals to 6 as it is, right? So integral of x will be x square by 2, limit value will be from 0 to x. 6 is outside, integral of x square will be x cube by 3, limit value will be 0 to x. You can just cancel out this values over here. 6 by 2 will be 3, upper limit value for x will be x itself, so x square minus lower limit value will be 0. So you can cancel 6 by 3 will be 2, upper limit value for x will be x itself, x cube, lower limit value for x will be 0. So if you multiply, you will be getting 3x square minus of 2x cube. So this represents the CDF for the PDF, probability density function. That's all I have for today. Thank you.